this class, we discuss about the calibration. Calibration is one essential part of the industrial measurement and control. It can be defined as the comparison of the specific value of the input and output of an instrument with the corresponding reference standard. It offers a guarantee to the device or instrument that is operate with the required accuracy and the range specification under the stipulated environmental conditions. Calibrated device permit the manufacturer or processor to produce a quality product with a desirable or required specification. By this process, the error and corrections are revealed. So, the calibration must be performed periodically to the test validate of the performance of the device or the system and require the use of the standard for comparison values. The comparison required operator skill, availability of the good reference standards and standard environments. Calibration does not guarantee the performance of the instrument, but is usually a good indication whether or not its performance can meet the accuracy and range specification for which the device is to be used. Then recalibration is carried out if the device has been adjusted, aged, repaired, modified, or abused at any time. The record obtained acts as the manufacturer verification and user evidence of the complaints. The accepted standards can be classified under three categories, that is primary, secondary, and working standards. What is the meaning of the primary standard? That is an extremely accurate and absolute unit certified by the National Standard Institution to be within allocated tolerance. These standards are very expensive to own and maintain. So in the primary standard, it is also called as absolute. So the absolute is used in the sense of being independent, invariant, and not related but finite. So the reference calibrated standard design and construct from absolute standards as termed as secondary standards. So this can be established at the number of institutions with traceability to the primary standards and calibration interval for secondary standards depends on the accuracy and the type of the standard being maintained. For example, in the company maintained the ISO 9000 certified means they should follow some rules for maintaining the instrumentation. So in the instrumentation condition, service, and how that machine is utilized to the user with the help of their production, that is output. The normal standard needed by the industrial establishment and the laboratories having one order of accuracy lower, then the secondary standards are termed as working standards. So the well-equipped industrial calibration facility should maintain primary standards and secondary standards, and also as associate calibration equipment for displacement, velocity, acceleration, force, pressure, flow, temperature, voltage, current, time, and frequency. Some of the standards normally maintained with the accuracy that is achievable by some standard of primary part and secondary part. In all calibration procedure is available to take a reading both in ascending and descending order. In a mechanical or electrical part of the transistors, that is normally reveals losses due to the friction, hysteresis, and similar type of the phenomena. The purely electrical device is the non-linearity and magnetic part of the working process. This is the calibration standards for the physical parameter. The first parameter is the displacement or velocity or acceleration. Their primary standard is the length standard with the krypton 86 lamp, that is 1 into 10 power minus 8. Motion measurement with the standard QGIS. Then secondary and working standard is precision micrometers and other gauges is 1 into 10 power minus 5. Gross coefficient. Then a primary laser interferometer is 1 into 10 power minus 8. The secondary and working standard is standard accelerometers is 2 into 10 power minus 4. The next parameter is the pressure. The primary standard is air dead weight tester is 3 into 10 power minus 8 minus 5 to 1 into 10 power minus 6. That is the range. Okay. The second and working standard is oil dead weight testers. Mercury and water nanometer is 1 into 10 power minus 5 to 3 into 10 power minus 4. Okay. The next parameter is the force or the torque. The standard dead weight is 1 into 10 power minus 7 to 1 into 10 power minus 8. The secondary and working standard is the precision tachymeter is 1 into 10 power minus 4 to 1 into 10 power minus 5. The next parameter is the flow. The flow primary part standard is volume, mass, and time measurement is 1 into 10 power minus 5. The secondary and working condition is that is range is 1 into 10 power minus 4 to 1 into 10 power minus 3. The next parameter is the temperature. Their precision potentiometers, boiling and melting point of the metals, that is 2 into 10 power minus 3 Kelvin. The secondary and working part is 20 into 10 power minus 3 Kelvin. Okay. So next parameter is the time or frequency. Time and frequency used by the some nano part of the processor, that is the time. The time is 0.2 nanosecond per day. The frequency is 1 into 10 power minus 12 per day. The secondary standard is time is 20 microsecond per day. Frequency is 1 into 10 power minus 10 per day. Then voltage and current that is affected, but the frequency is 1 into 10 power minus 4. The secondary and working standard is 1 into 10 power minus